Magnets in the textbook from pages 1502 to 1507. Magnets, in some ways, are like charges. Notice the word polarized, meaning that magnets have poles. The important thing here is your first note-taker question is right here. A compass, which is what we're going to use to measure the direction of magnetic fields, is simply just a small magnet that's free to rotate. This shows that the Earth is also a magnet, and that's why compasses always point to the North Pole. Fun fact, you might read here that because compasses point, the red end of a compass is the north end of the compass. North attracts to south. So the North Pole, as we call it, is actually the Earth's south pole of the magnet. You might have noticed that if you take a magnet, you can make other magnets. For example, this magnet, permanent magnet, is used to magnetize the nail. As we'll talk, it's lining up the domains in the nail and making it a magnet. Once the nail's a magnet, it can pick up paper clips and align the domains inside the paper clips. This process is called induction. Not everything, not all materials become magnets. Certain transition metals in the periodic table are the ones that become magnets, namely iron, nickel, and cobalt. Now this page is very important. First off, it answers the question in the note taker, what are the world's smallest magnets? And the answer is atoms in ferroelectric material act as tiny magnets. But that alone is not enough to form a magnet that we can pick things up with. These atoms form what's called domains, which are small groups of atoms clustered together on the atomic scale. You can see here a picture showing domains. In a paperclip, these domains are randomly oriented, and the paperclip generally is not a paperclip. Is not a magnet. However, when you place the paperclip in an external magnetic field or B field, all the domains line up and the paperclip becomes a magnet. Or in the previous picture, the nail becomes a magnet. When you take the B field away, remove the permanent magnet, temporary magnets just go back to being non-magnets. So, how are permanent magnets created? Well, permanent magnets are created when you heat up ferromagnetic material in the presence of a strong magnet. So for instance, on the Earth, lava is hot and it gets aligned in the magnetic fields of the Earth, and when it cools off, the domains stay aligned even after the magnetic field is removed, and we have a permanent magnet. That covers magnetism.